Hello everyone, it's really good to see you here. So today we are going to look at a technique which is insertion sort. So how we can actually apply this particular technique to sort our given vector or array is that, let's suppose we have given this vector initially, and what we have to do is we have to just sort it according to, we have to just sort it. So what this technique do is, let's suppose we have two pointers I and j. What we firstly do is we check that if if I and j are similar position, there is no like both are identical, right? What we do, we just in the next step, when we increment our counter I, now I is at this position and j is at this position. So what I do, it's just check that if this particular element is less than, is basically less than the consecutive or adjacent element, that is 6, then what we do, we just uh, make 1 at this position and 6 at this position. Now again, so it is what it is basically doing is it is taking one element and then it is inserting it to a certain position, which is according to it is the is the required or is the possible um, place to the element to be there. So what I mean is that, let's suppose 8. So you can see that 8 is largest among all these two elements. That's why we increment our count here. So let's look this approach in a bigger picture like this. So let's suppose we are at index, this I is at this element 0. So firstly we have this, right? So we have 16803. Now what we do, we just store this 0 somewhere in some temporary integer, and then what we do, we just check this temporary element with the j minus 1, that is, so I ranges uh, basically j ranges from 0 to I, so it is range from 0 to I. So it checks each and every possible element from this particular index, that is, let's suppose this is I, so j goes till here. So what we do, we firstly check that if if this element is smaller than this element, that is, the index ith element is less than index jth element, so what we do, we just insert that 0 here. So we basically didn't insert it like this, but what we do, we just shift. So if you can see in a broader picture, so there is some shifting happening. So firstly we are comparing it with this. Now if here is 0, then we are comparing 0 with this, so six shifts here, and after that we are comparing 0 with 1. So at the end of this whole shifting operation, we place 0 at its right position, at least as of now. So after doing this, so let's suppose instead of 0 it is some value 2 or something else, so we place it over here, and after that if some element 0 comes again, then we have to shift it, right? So this insertion sort is basically, if you have some element, you firstly pick that element and then you check, like whatever the previous element you are come up with, just check if that element is smaller, or like place at it's at this position, that is, it is smaller. So what I mean is that zeroth most preferred location would be less than 1, that is at 0, that is at here. So if it is a element 2, then its most preferred location should be this. So this is how we are actually doing our insertion sort. And again our I is at this position, so we come at this position. So again 3 is, like, we compare 3 is less than 8, also 3 is less than 6, but 3 is greater than 1, so we put 3 at this position. And after that, since we are done with we are reached till maximum uh, possible length, that's why at the end of this we got a sorted vector as our answer. So let's try to look the code of it. So here firstly n is basically representing the size of the vector, and basically in j is having the ith index, and int temp is storing the ith index value, so v of I. Now what we do, we just run a while loop till the point j is greater than 0, and v of j minus 1 is, let's suppose our I is at this position and j minus 1 is basically this. So we are going to compare 0 and 8. So you can see that the value at, so basically this is stored in some variable temp. So we compare that temp is basically less than v of j. So what we do, we just make v of j as v of j minus 1. So that is, uh, you can see that v of j is basically this. So this will become 8. This will become 8. And after that, now our j is, now in the second iteration, our j is pointing to some this position. J is pointing to this position. So here it is, here it is also 8. So what we do, we just we just check that this j and j minus 1. So basically what happened is that, so we do this operation till the point are basically we are comparing each j minus 1 element with our temporary integer, let's suppose temp, which is storing 0. So we compare. So again you can see that in the second iteration this will be going to be 6, that is this would be going to be j minus 1. And again here you can see that this would be going to be 1, and at the end 0 stores here. So this is some of the technique which is going to be happen. So basically you select one element and you check each and every corresponding element to it and just insert it at its right position. So after doing that, we got some j value for which we stop. So at v of j we basically make it as temp, because this element has to be, so you can see that since our j reaches till this position, that is j is equal to 0. So what we do, we just make our v of j, so here it is 1, right? Here it is 1, so we just make it 0. So this is the thing which we are doing here. So this is the approach. Then we have taken some input and applied insertion sort to it. So let's try to run this up. I can make this different. So yeah, so basically we got the sorted vector. So this is the approach for the problem or for the technique insertion sort. And if you want to access the code, then you can check the GitHub link given in the description. And last but not the least, do subscribe to the channel, and thanks for watching.